For any assignment-related queries, call us at +1 678 648 4277. You can mail us at info@mathsassignmenthelp.com, info@mathsassignmenthelp.com, or reach us at www.mathsassignmenthelp.com. Problem 1. Use the definition of the derivative as a limit of difference quotients to 1. Compute the derivative of y equals x plus x for all points x greater than 0. Show all work. Problems and solutions. Solution 1. Denote by f, x, the function x plus x. By definition, the derivative of f, x, at x equals a is the increment f, a plus h, minus f, a, equals, to compute the second term, clear denominators, thus the increment f, a plus h, minus f, a, equals, factoring h from each term, the difference quotient equals, mathsassignmenthelp.com. Thus the derivative of f, x, at x equals a equals. Therefore the derivative function of f, x, equals. Problem 2. For the function f, x, equals e minus x2/2, compute the first, second and third derivatives of f, x. Solution 2. Set u equals minus x2/2 and set v equals eu. So v equals f, x. By the chain rule. Since v equals eu, dv/do equals eu equals e. Since u equals minus x2/2, do/dx equals minus 2x/2 equals minus x. Thus, back substituting. For the second derivative, let u and v be as defined above, and set w equals minus 15. So w equals f, x. By the product rule, mathsassignmenthelp.com. By the last paragraph, substituting in, for the third derivative, take u and v as above, and set z equals x2 minus 1 v. So z equals f, x. By the product rule, by the first paragraph, substituting in. mathsassignmenthelp.com. Extra credit only. Attempt this after you have completed the rest of the exam and checked your answers. For every positive integer n, show that the nth derivative of f, x, is of the form f, n, x, equals Pn, x, f, x, where Pn, x, is a polynomial. Also, give a rule to compute Pn plus 1, x, given Pn, x. Solution to extra credit. The claim, proved by induction on n, is that for every positive integer n, f, n, x, equals Pn, x, where Pn, x, is a degree n polynomial, and the solution to problem 2 proves this when n equals 1, 2 and 3. Let n be a positive integer. By way of induction, assume the result is proved for n, precisely, assume f, n, x, equals Pn, x, e minus x, where Pn, x, is a degree n polynomial. The goal is to prove the result for f, n plus 1, x, precisely, f, n plus 1, x, equals Pn plus 1, x, e minus x2/2 for a degree n plus 1 polynomial Pn plus 1, x. By definition. By the induction hypothesis, this equals. mathsassignmenthelp.com. Let u and v be as above, and set y equals Pn, x, v. So y equals f, n, x. By the product rule, as computed above, substituting in, since Pn, x, is a degree n polynomial, Pn, x, is a degree n minus 1 polynomial, and minus x Pn, x, is a degree n plus 1 polynomial. Thus the sum minus x Pn, x, plus Pn, x, is a degree n plus 1 polynomial. Defining Pn plus 1, x, to be, this gives, so the result for n plus 1 follows from the result for n. Therefore the result is proved by induction on n. Moreover, this gives the inductive formula for Pn, x. mathsassignmenthelp.com. Problem 3. A function y equals f, x, satisfies the implicit equation. The graph contains the point, 1, 2. Find the equation of the tangent line to the graph of y equals f, x at 1, 2. Solution 3. Differentiating both sides of the equation gives, because the derivative is linear, of course dx3 slash dx equals 3x. By the product rule, for the last term, the chain rule gives, substituting in gives. mathsassignmenthelp.com. By the first paragraph, d slash dx, 2x3 minus 9xy plus 2y3 equals 0. Substituting in gives the equation, subtracting the first term from each side gives, dividing both sides by 6y2 minus 9x gives, finally, plugging in x equals 1 and y equals 2 gives, therefore, the equation of the tangent line is, which simplifies to mathsassignmenthelp.com. Problem 4. The point, 0, 4, is not on the graph of y equals x plus 1 slash x, but it is contained in exactly one tangent line to the graph. A. Find the one value of a for which the tangent line to the graph of y equals x plus 1 slash x at a plus 1 slash a, contains 0, 4. Hint, you do not need to solve a quadratic equation to find a. Solution A. By the solution to problem 1, the derivative of x plus 1 slash x equals. Thus the slope of the tangent line to the graph at x equals it is. Therefore, the equation of the tangent line equals. This simplifies to give the equation. mathsassignmenthelp.com. By hypothesis, 0, 4, is contained in the tangent line. Plugging in x equals 0 and y equals 4 gives, multiplying both sides by a gives dividing both sides by 4 gives, at equals 2/4 equals 1/2. B. Write the equation of the corresponding tangent line solution. B. From the computation above, the equation of the tangent line at x equals it is. Plugging in a equals 1/2 gives. And mathsassignmenthelp.com. Therefore the equation of the tangent line equals. Problem 5. In an automobile crash test, a car is accelerated from rest at 2 meters per square second for 5 seconds, and then decelerated at -4 meters per square second until it strikes a barrier. The position function is A. Assuming that both st and st are continuous at t equals 5, determine A and B. Solution A. Because st is continuous at t equals 5, the left-hand limit and the right-hand limit are equal. The left-hand limit is, the right-hand limit is, this gives the equation. mathsassignmenthelp.com. Which simplifies to, the derivative st equals. Which equals, because st is continuous at t equals 5, the left-hand limit and the right-hand limit are equal. The left-hand limit is, the right-hand limit is, this gives the equation, 10 is equal to -20 plus a. mathsassignmenthelp.com. Which simplifies to, a equals 30. Plugging in a equals 30 to the first equation gives. Which simplifies to, b equals 75 minus 5. 30 equals 75 minus 150 is equal to -75. Therefore, the solution is B. The barrier is located at s equals 33 meters. Determine the velocity of the car when it strikes the barrier. The quadratic polynomial has whole number roots. Solution B. For t greater than 5, the equation for displacement is st equals -2t2 plus 30t minus 75. The moment t when the car strikes the barrier is the solution of the equation st equals 33 minus 2t2 plus 30t minus 75 is equal to 33. Subtracting 33 from each side gives the equation. Minus 2t2 plus 30t minus 108 is equal to 0. mathsassignmenthelp.com. Dividing each side by -2 gives the equation, t2 minus 15t plus 54 is equal to 0. The fraction 54 factors as 2 times 27, 3 times 18, and 6 times 9. In the last case, the sum of the factors is plus 15. Thus the quadratic polynomial factors as